Thank you.
Appreciate it.
Okay, hi, my name is Kristen John, and I'm a researcher at NASA Johnson Space Center. I work with Paul Abel, who I'm sure many of you know. He comes to almost every SBAG. So I'm here to talk about Hermes. It's an experiment called Hermes on the space station. So to capture your attention, I put asteroids on the ISS because that's what we're studying, asteroids on the ISS. And so many of you are probably aware the ISS is a wonderful place to study asteroids because of the microgravity environment that we have. Okay, so what you see here is a picture of Hermes. So Hermes is a microgravity research facility on the ISS for studying asteroid regolith and granular materials. So that's our scope, asteroid regolith and granular materials. So it is a facility. So the idea is we've actually launched this just a couple months ago. It's on the space station right now. And the picture that you see on the right, that's the facility. So that will stay on the space station. So for those familiar with the ISS, it's installed into an express rack and it will live there permanently. So the picture on the left is what we call a cassette. And this is the science package that is integrated on the ground and then installed into the facility. And so this is what users can build and send to perform their research. So now you can see the facility on the right, the door is open. So you can see the empty volume inside. So what we've tried to do is build a facility that has as much space as possible for the actual science. So the cassette on the left is inserted into the facility on the right. So it's very minimal crew time. The astronaut pretty much just installs the cassette inside the facility, shuts the door, hooks everything up, and then it runs autonomously. And then we do some ground commanding here. And so one thing I want to make sure you're all aware of, if you haven't already figured that out, is it's open to users. So it is a facility. The whole idea was for us at Johnson Space Center to create this facility that was easy for scientists to use so that you weren't burdened with the process of sending hardware to space. So we've taken on that challenge and we've tried to make it easy for you to perform science, to put your science inside of our experiment containers and send it quickly to the space station. So there's 4 experiments at a time. So you can see on the cassette on the left, you can see I'll show you another picture, but there's 4 different experiments inside one cassette. So experiments about this big. So for those that can't see me, I'm holding my hands about like the size of a can of tennis balls or a can of Pringles. And so there's 4 of these in one cassette. So the idea is that the user that would put the science experiments together would have 4 different experiments. Okay, so just a little bit more about what Hermes offers. So starting at the top right, vacuum. So we're hooked up to the vacuum resource system on the space station. So you basically have your very own port to space. So you can get a vacuum pulled inside of your experiments. So daily downlink of data, all the data that we've collected, which we can collect tons of data, we can pull down actually more than daily, but that's just how we've kind of optimized it. So you can get data in almost near real time. Actually, you can get it in real time, but we just won't downlink it that often. So long duration exposure to micro G. So this is a huge plus. So I know lots of us here in this room have done different parabolic flight studies and suborbital flight studies. But what the ISS buys you, of course, is this long duration exposure to micro G. So long duration can be defined by the user. If you need 3 months, probably up to 12 months would probably be the upper limit for a set of experiments. So acceleration monitoring. So you can see on the facility on the right, this gold package right in the middle. So that's an accelerometer and it's an ISS provided piece of hardware. It's a triaxial sensor. And so you can basically capture all of your accelerations. And so this is really interesting because we have, dynamic movements on the space station, whether it's an astronaut kicking off of our experiment or a Soyuz docking, for instance. We're interested in these accelerations, but we just need to be able to characterize them. So we can do that. And then ground commanding. So like I mentioned, so after the crew installs us, they pretty much leave us alone and we do all of the control from the ground. So we have different tools inside of the experiments that I'll show on the next slide, but you can actually do all that controlling from the ground. And we have cameras that observe the experiments. You can control the cadence of the picture taking, for instance, from the ground. And even the downlink, if you need data down more quickly or less frequently, all that is controlled from a ground station. And then imagery. So each of the 4 experiments have a camera pointed at it. So the imagery, we can do almost as fast as video. So actually we can do video for limited times if we need to. And so the imagery is basically, that's the main piece of data that we collect. And so you can string this together into a time-lapse video. Okay, so here's a picture of the experiments up close. So I mentioned the 4 different experiments. So that's what you see here. And so for those that are interested in cassette 1, the first set of science experiments that we've put together, I'm happy to talk with you during lunch or during one of the breaks. But you can see there's some pretty different simulants inside of each of these tubes. And then you can see a little device. It kind of looks like a scissor jack device. This is actually something that holds the material in place during launch. And then when we get up there, we pull this device back and the material can move around. And then what's really interesting, so folks may have heard of an experiment called Strata-1. This is a heritage mission that flew on the space station in 2016 that the same team worked on. Hermes is trying to be bigger and better than that. So a lot of the capabilities we have, we didn't necessarily have on Strata. And one thing that we have is this, the idea of what we're calling tools. And so the tools are basically sensors or mechanical devices or any sort of electrical component that you can envision that can go inside of the experiment tubes. So in each of those 4 tubes, you can have up to 7 tools. So that could be 7 force sensors or load cells, for instance, or like we have a vibrating motor in one of them, or maybe another sort of penetrometer to poke at the material. And all that, again, is commanded and controlled from the ground. And then you can also, as the user, select the commands to decide how often to use these tools. And then, of course, the simulants is up for selection from the user. I should note too, this form factor that we've used for Cassette 1 isn't necessarily how Cassette 2, Cassette 3 has to look. That's just what we're envisioning. That's the easiest way to quickly put your science on the space station. So if you're interested, if this sounds at all like something, if you have an idea for something that we could study, to study asteroid regolith or granular materials on the space station, reach out to myself or Paul Abel. There's other folks I should note here in the room. Christine Hartzell is part of one of the science team members for Strata and for Hermes, and a lot of folks that regularly come to SBAG that have worked with this. And so there's probably folks that have used this for science. We produce a lot of data. Eventually the data will be available for folks to use on the Planetary Science Database. And so we're hoping yourselves and your early career grad students and postdocs can actually analyze some of this data and make some really good observations with it. Thank you.
We have time for any questions.
Yeah. Hey, Kristen, Dan Masick, NASA Langley. You mentioned that you have a tool for a vibrating motor.
Yes.
Is that just in one of the canisters?
In our experiment in Cassette 1, it's just in one of the canisters.
So do you have a vibration isolation system between the canisters to prevent?
No, we don't. It's a very subtle vibration. It's very similar to like the vibration you'd see on like your iPhone if your iPhone were to ring.
Okay.
But no, we don't. But we do have the acceleration monitoring on the facility. So, and we'll control when we vibrate that motor. So when we vibrate it, we'll know exactly what time we did that, and we can look at the accelerations that our experiment experienced.
Across the other canisters.
Exactly.
Okay, thanks.
Hey, Christine Hartzell, UMD. So if somebody would like to propose to use this facility, how would one go about doing such thing?
That's a great idea. That's a great question. So the first step at this point is to reach out to me or Paul or even Christine to get more information on Hermes. And so we're actually working on that process. We're defining that at JSC this summer and pretty soon, actually, we're going to put out hopefully the website. So it'll be just a NASA website that we have through JSC. And this will sort of be your portal that has, what type of experiments have been done and what type of experiments can be done. And so the idea that, users, we've tried to make it simple and relatively low cost for users to use this. So there'll still be a cost associated with using it, but it's minimal compared to typically sending things to space. And so the idea is you could go to the website and get ideas. If you had, a relatively idea similar to Cassette 1 where you were maybe just changing the simulants and the tools, that would be easier and faster and cheaper to send and to get integrated onto the facility. If you wanted to use that empty volume and totally change the form factor that we've used, that would take a little bit more.
Paul Abel, NASA Johnson. So Kristen, maybe just for people online and in the room who are not familiar, talk a little bit about the timeline for how long the experiments are up.
Sure.
And the fact that you get the experiments back.
Yes. Yeah, sure. Yeah. So so when we launched the facility, we launched Cassette 1. And so the intention for Cassette 1 was to operate for about a year. And so we're actually hopefully being installed and activated in mid-July. And so that will go for approximately a year. And so in the meantime, there's development of Cassette 2 happening. And then, and that will operate. Again, we have to prioritize the science based on when the next cassette is ready to go. And so, so anywhere from 3 months to 12 months for a cassette. So like I said, there's 4 experiments inside of a cassette. So if you wanted, one of them to last for 2 weeks and one to last for 6 months and the other to last for 9 months, whatever, we could do that. We can do all that commanding and controlling from the ground. So again, you'd still be exposed to the vibrations of everything going on up there. And then you do get your cassette back. So the idea, so down mass coming from the ISS is not as challenging as up mass. And so any experiment that needs to come back, it's expected that we'll just bring them all home. And so that little device we mentioned, the entrapulator, that will actually at the end of the experiment hold the material in place and then come back down. And then, theoretically could look at the ending position of your experiment if the landing loads didn't mix them up too much.
Thank you.